Hi there, thanks for joining us on a Q&A edition of Space Nuts. Andrew Dunkley here. Hope you're well. Hope you can stick around a while because we've got questions from all over the world and they will be focusing on gravitational waves. An interesting question about how they behave, or do they behave in certain ways. We're going to talk orbiting space stations and super constellations, which is certainly an issue around the planet at the moment. An observation, I suppose, with a question as the kicker about dark energy and ultra-mass black holes and non-compatible spacesuits has been brought up again. We'll talk about all of that on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
He's back. I don't know why he keeps coming back, but he's back again. It's Professor Fred Watson. Hello, Fred.
I'm only back because I can't actually get out of this room. I'm just locked in here all the time.
Yeah, so yeah. I mean, for I say you never left.
No, it's the TARDIS effect.
Shall we get straight into it and answer some questions?
I think we should, yes.
Or at least pretend to. Okay. This first question comes from Colin. I'm not sure where Colin is, but he asks, is there any evidence that gravitational waves reflect and or refract like pressure or light waves? I know we've talked about gravitational waves a lot, but I don't know if we've really analysed this particular aspect of their behaviour, if it exists at all.
We haven't, and it's a good question because we know that light waves, which are transverse waves, so like things are vibrating kind of horizontally or vertically, they are refracted and reflected, and sound waves are too, which are pressure waves. They're longitudinal waves, so changes in pressure. Now, gravitational waves are neither of those things. They are quadrupole waves, which means that space is sort of distorting in a peculiar way when they travel through. But here's the crunch, Andrew, and there's Geordie agreeing with me, which probably means that he's back, so he'll go berserk in a minute, but that's all right. Here's the crunch. So think about refraction. This is the bending of light when light passes into, for example, a piece of glass. Why does light refract in a piece of glass? Why does its angle change? And it's because the speed of light in a piece of glass is lower than it is in free air or a vacuum. And so the light waves are slowed down when they pass into the glass, and that produces the bending phenomena, refraction. Now, gravitational waves are not like that. They always travel at the speed of light. So they're not refracted in the same way that we would imagine light being refracted. That phenomenon doesn't exist for gravitational waves. What does exist, though, is we know that space-time is distorted by matter. That comes from Einstein's general theory of relativity. And space-time is distorted, but light wants to follow the distortion. In other words, the light doesn't know that it's going through distorted space-time. And so it just follows the distortion. And that's why we see gravitational lenses, because the space-time around a cluster of galaxies is distorted. The light just goes on its merry way at the same speed. And it's not refraction, it's gravitational lensing. It's bending by gravity. And gravitational waves behave in the same way. So they do bend, but it's not through refraction. It's through gravitational distortion of space.
Work that one out. So that means gravitational waves just keep going.
They go in what they think is a straight line, but the straight line isn't straight because because the space is distorted by They're called geodesics. It's basically how. So that's the way we believe orbits work in relativity. If you've got a planet that's got something in orbit around it, the planet produces a well of gravity. You can think of it as a trampoline distorted, and an object basically thinks it's going in a straight line through that distorted space, but actually it's going round in a circle in an orbit. That's sort of, and the same thing kind of happens to both light waves and gravitational waves. They think they're going along a straight line, but they're not, because the straight line's bent by gravitational pull. I'm not explaining this very well. I can see that. I can see by the expression on your face that he's thinking, he's lost it altogether. I have no idea what he's talking about.
What kind of bent my mind out of shape is I expected you to say the opposite. I expect you to say, no, gravitational waves, they're a power unto themselves and they will do what they like and nothing will stop them from hitting a straight line. But that's not true, although they think that.
Well, it is. They behave as though they're following a straight line, but that straight line's distorted by the gravitational pull of something else, like a cluster of galaxies.
Yeah, so they are affected.
They are affected, yes. But it's not quite the same as reflection or refraction as Colin's proposed.
Interesting. Very interesting.
It's a great question, Colin, and thank you for that. Yeah.
Absolute ripper. All right. Thanks, Colin. Our next question comes from Michael Whiting in Cromer in the UK. Hi, Andrew and Fred, long-term listener, and would like to say thank you for a brilliant podcast, which I look forward to every week. Thank you. Thinking about the future, going back to the moon, etc., is it possible to have a space station orbiting both Earth and the moon in, say, technical terms, a figure 8? I'm assuming it is possible, but radiation shielding is more the issue. This would surely make it easier to transit for moon missions. That's his first question. When we deal with that one, I'll ask the second question.
All right.
I like this idea, if it's feasible.
Well, it is, absolutely. And that's actually, if you look back to 1968 and look at the trajectory of Apollo 8, that's exactly what it did. It followed a figure 8 orbit around the Earth and the Moon. That you could set up a stable orbit like that. But it doesn't really make for an easier transit for moon missions, because if you've got something that's in a figure of 8 orbit, it's going from Earth to going between the Earth and the Moon. When supposing you imagine that's a kind of space station, you want to jump on board it. To jump on board, you've got to have a spacecraft that is following exactly that orbit. So you've got to launch it and get it into that orbit in order for you to make the rendezvous between the two. Now, yes, maybe if you have something like the Gateway satellite, which is being proposed as part of the Artemis program in orbit around the Moon, then that's like a space station which has lots and lots of facilities on board, which a little transit shuttle might not have. A transit shuttle might look more like a Crew Dragon spacecraft, or what were they called? I can never remember its name. The Boeing one.
Oh yeah, Starliner.
The Starliner. That was the name I thought of, and I was thinking, no, it's not a Starliner. That's an aircraft. No, but it is. It's a Starliner. Yeah, the Starliner. So they're very modest pieces of equipment. They can hold up to 7 people, but it will be a crowded house. So I guess you could do that if you've got this sort of Gateway-like space station that is constantly in a figure of 8 orbit, and you zoom your passengers up to it, hop on, and it acts like a bus. Then you've got to hop off at the other end before it brings you back to Earth. I'm not sure that it would make life easier. I think it might make life a bit more complicated.
But it could be done.
Yes, it could be done. Yeah.
All right. So your thinking is right, Michael, but operationally might prove too much of a headache.
Yeah.
Michael's got another question. With China adding a new currently visible satellite constellation, are discussions being had to decrease the visibility of the satellites as was achieved with SpaceX Starlink constellations. Follow-up question to that, does China listen? Thanks, Mike.
And this question goes right to the heart of stuff I talk about a lot, and part of my role as the astronomer on the loose. The answer is yes. Qianfan, I think, is the name of the satellite. I might have that wrong because it's a few days since I looked at it. It means 1,000 sails. That's the name of it. And there are 15,000 satellites, I think, have been filed for in this constellation. All the evidence, I think last time I looked, there were about 40 in orbit now, with mounting evidence that they are pretty bright. Then as you exactly as Michael says, SpaceX did a lot of work to reduce the visible light profile of their Starlink satellites. We don't think that's happened with Qianfan, and we don't really have any avenues into the company that is running them in China. Now, my hope is that this will change because we now have satellite constellation interference to dark and quiet skies. That is now an agenda item on the Committee on the Peaceful Uses of Outer Space, the UN Committee on the Peaceful Uses of Outer Space. They have a science and technical subcommittee, and it's now an agenda item on that committee. So that raises its profile. China is a player in this forum. They come to the party with the COPWAS, that committee. So my hope is that there will be avenues for improvement with that. But at the moment, we don't know.
Yeah, that's a pity. I mean, they have a vested interest in space exploration and understanding as much as anybody else. So I suspect that it would be in their best interest and they would benefit from insulating their satellites, so to speak, to reduce the impact on observational and radio astronomy.
From the ground, that's right. In fact, that's exactly the comment. I was in a meeting a few months ago now, and I made exactly that comment, that China has a very large cohort of astronomers who are themselves using, well, amongst it, the biggest single-dish radio telescope in the world, the FAST telescope, 500-meter radio dish, and they also have optical telescopes. So they would have a voice within China, and hopefully the space industry in China will listen to them. So my, I'm an eternal optimist, Andrew, as you know, but the answer to Mike's last question, does China listen, is we hope they will.
Yeah, fair point. And really great question to ask. Probably it's a scary question to ask because you don't know with China. They get offended at things out of the blue and they stop buying our wine and trades.
It was $20 billion worth of trade. Exactly.
Yeah. Anyway, great questions, Mike. Thanks for sending them in. This is Space Nuts. Andrew Dunkley with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Yep, it's a Q&A edition where we answer audience questions, and we've got an audio question now from one of our regular sender-inners. It's Rusty from Donnybrook.
And Andrew, it's Rusty in Donnybrook. When the dark energy said, "You really suck," what did the ultra-massive black hole say in response? Nothing. He was too taken aback to get a word out. Now, if black holes truly generate dark energy, it's got to be a local phenomenon, because our study of gravitational waves have shown us that space-time distorts at the speed of light. The effect would be too small to be able to measure it in stellar mass black holes, but as we get bigger, the effect would be too cluttered. in supermassive black holes in galaxies too. So that leaves ultramassive black holes in the centre of large voids, if there are any. So how would an astronomer specialising in multiple object spectrometry, Fred, make observations to gain support for the existence of such ultramassive black holes and the granular nature of dark energy? So this would replace the notion that large-scale structure of the universe was caused by sonic oscillations in the early universe too. So thanks, Space Nuts. Have a good one.
Thanks, Rusty. I'm always worried about Rusty because he just tries to throw you a curveball occasionally, Fred, and I don't know if he's just tried again.
Yeah. I mean, the lovely thing about Rusty is that in 3 minutes, he rewrites all the textbooks. It throws away the Big Bang, throws away dark energy. It doesn't throw away the Big Bang. But I see where the point he's making, because we've covered this idea before that the ultimate source of dark energy might be black holes. That's some research that I think was done earlier this year. Mm-hmm. And so Rusty's conclusion from that is that dark energy must be clumpy, which I think is a reasonable conclusion, but I don't know that is the conclusion that's drawn by the people who are the proponents of this theory. I'd need to go and have a look back at the theory of black holes being the source of dark energy. But if there were, so look, I'll rise to the challenge as a multi-object spectroscopist, which I'm not really anymore, but I was. I wouldn't. This would not be the technique that you'd use, though, to detect them. So what Rusty's proposing is that there are these things, ultramassive black holes, which I guess we might say are more than 100 billion times the mass of the sun. They're monsters, absolute monsters, but they're lurking around in the voids between galaxies. Now, those voids are part of the sort of honeycomb structure of the universe that we think was imprinted in the Big Bang. That the work that people do on the physics of the Big Bang event tell you that there will be these strings of dark matter which would collect hydrogen gas, which would form stars and galaxies. And so, but those strings and sheets of dark matter make essentially what looks like a foam or a honeycomb pattern when you look on very large scales. So in the middle of that, there are very few galaxies. So if you put an ultramassive black hole in the middle of that, what would you see? And the answer is you would expect to see, when you looked in that direction, because you'd be able to see the galaxies on the far side of that void, a sheet of galaxies, you would expect their images to be distorted in the way that we are familiar with gravitational lensing by a massive, massive object. And so I don't believe that such distortions have been found. In other words, what you might see is nothing because there's a black hole. You see no evidence of something in the intermediate distance, but in the far distance, you'll be able to see galaxies and clusters of galaxies whose light will be distorted by the black hole that you couldn't see in the foreground, if you see what I'm saying. So I think we have evidence already of such ultramassive black holes.
Okay, so a void with a black hole would give you a vision of distorted galaxies behind it, whereas a void without a black hole, you just wouldn't see anything.
No, you'd see the galaxies, but they wouldn't look any different from what they normally look. Yeah,
right. Gotcha.
You can. We know particularly from the new Webb images, just how distorted the shapes of galaxies are when they're seen through a gravitational lens caused by a cluster of galaxies in the foreground. So yeah, it's an interesting question though, as Rusty's always are.
Yeah. He's always thinking. That's the thing, and that's what it's all about. To provoke thought and come up with ideas and try to challenge those in the astronomical seats of power, such as your good self, Fred. Always throwing out the challenge. Thank you, Rusty.
G, and I feel fine.
Space nuts.
And our final question reflects on an issue we spoke about fairly recently. This comes from Mark.
Hi, it's Mark in London in Canada. I was wondering, you were talking recently about the astronauts being stranded and the Boeing spacesuit being incompatible with the SpaceX vehicle. I was wondering, what does that mean? Why can't they just wear their suit? What does the suit plug into the vehicle? Or what's the incompatibility? Appreciate an explanation on that. Thanks, guys. And I figure Hugh's been in that studio for the best part of a decade, so it's time to free Hugh. We can just start a campaign to let him go home. Thanks. Bye.
Start a petition, Mark, because I'm not going to help him. Gosh, people are starting to sympathise with Hugh. It's starting to worry me a lot. I'm sounding really evil now.
You are, yeah. You know, I think Hugh deserves a break. Really, he's got us to put up with for a start.
Yeah, well, that's true. That's very true. Mark asks about spacesuit compatibility. Now, we go back to that situation where there were, I think, was it 3 astronauts on the International Space Station who couldn't get back on the Boeing Starliner because of a fault, so it was sent back empty, and they were to be returned on a SpaceX rocket, if you like. But their suits, the Boeing suits, didn't work in the SpaceX vehicle, and there was talk about sending them back in their underpants or something because they just, their suits were useless.
That would have been an emergency. Yeah, that's right. It would two astronauts, not 3 as well. It's sort of Tony Williams and Butch Wilmore.
That's right. Yeah. Well, and they ended up coming back. Are they still there?
Yeah, they don't come back till February.
Oh, that's right. Yeah, that's right. The Boeing Starliner's back, all good and well, but they're still up there. Yeah. Mark's question is a good one. Why can't they just wear their suits? What's the problem?
So what's happened is that when the SpaceX, it's not a rescue vehicle because it was already scheduled, but when that SpaceX craft went up to rendezvous with the ISS, which was last month, was it, or earlier this month? I can't remember. I think it's last month. It took SpaceX suits up with it. It had a crew of only 2 rather than 4, and 2 empty suits for Butch Wilmore and Sonny Williams to come back with. Why do they need that? Well, the Starliner and the SpaceX Dragon capsule are completely different. They were developed independently, and in many ways, NASA wanted 2 different ways of transporting their astronauts up and down to the space station, because it gives them a choice. That's the thing, and it turns out that it's just as well that they did, because the SpaceX has had far fewer problems than Boeing have. If we'd been waiting for Boeing, we would still be waiting, whereas Crew Dragon has been flying, I think, since 2020 or thereabouts, quite a while ago, maybe 2022. Anyway, they're different spacecraft. They've got different, umbilical fittings. They have different restraint fittings, and entirely different appearance. The way to check this out, Mark, is to have a look at the USA Today website, and there is a story on that which is entitled, "You Can't Use Starliner Spacesuits in a SpaceX Capsule. These images show why." And it becomes very obvious because all the plumbing's different. The spacesuits are themselves quite different. They've got different helmets, different fittings, different boots, different gloves. Everything's different. And they're not compatible. That's the bottom line. But it's a very nice article, actually. It's got some lovely diagrams and illustrations showing the differences there. usatoday.com is the place to look for that.
I just found it, and I'm just having a quick squiz through it. And yeah, you're right. There's some great diagrams and information in there. And now, just to clarify it a bit more, I assume when you come back to Earth, you can technically do it without a spacesuit. So it's not like you have to have the suit on so that you can breathe or anything like that.
No, that's right. It's basically a precaution. If on re-entry the spacecraft sprang a leak, for example, and started depressurizing, if you didn't have your spacesuit on, you'd be in big trouble. But that's an unlikely event. I don't think it's ever happened before. So it's they could have done it exactly as you've said. Had there been an emergency, those astronauts, Sonny Williams and Butch Wilmore, could have come back in a Crew Dragon flight. I think they were rigging up sort of emergency seats in one of the Crew Dragon craft just in case this needed to happen. But yeah, they wouldn't have had a spacesuit. So it would not have been possible for them to wear spacesuits on their way back. But that will not now be the case. That's fixed because there are now 2 extra SpaceX spacesuits on the International Space Station for them to come back when they return in February. And I do like, that article that I just mentioned, the one you've just found. It's got a really nice diagram of what we mean by redundancy. Redundancy is to build in safety precautions, and you can either do similar redundancy or dissimilar redundancy. And it's dissimilar redundancy that we're talking about here. 2 independently designed systems performing the same task in 2 different ways.
Yeah, it sounds like VHS and beta.
Maybe so. Yes, that's right. Yeah.
It reminds me of race car drivers. I mean, you could drive a race car in your underpants, but it's much safer to wear the fire retardant suit.
That's correct, of course.
And a helmet. Yeah,
absolutely.
Exactly.
Yep.
All right, Mark, thank you very much. Great to hear from you. Thanks for all the questions. And if you have questions for us, please send them through via our website. You just go to spacenutspodcast.com or spacenuts.io and click that little thing at the top that says AMA, and you can just fill in the blanks with the Ask Me Anything option in the form of a text question, or you can just hit the Start Recording button and send us an audio question. Don't forget to tell us who you are and where you're from. And while you're listening to us online, please leave a review on your podcasting platform. Reviews are very helpful. They get us noticed by more potential listeners, and that's what it's all about. Thank you, Fred. We're done and dusted. Good job.
Sounds great. Thanks, Andrew, and we'll talk again soon.
We will indeed. And am I going to release Hugh from the studio today? No, I am not. And I've kept him on mute for the entire episode. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.